one thing which really caught my attention, and I think we can explore that together after, is this ependyma, which Bonnie mentioned often, and I wanted to get a different image of it than because she always draws it more schematically as just as a line, but and she mentions that there are the cilia and there's a movement of the CSF. So I found these two images interesting, which I just found from Google. Um, and in the bigger one, even saying that they propel the CSF and there are regulate the migration of neuroblasts. So there is this movement up, and also that with age, maybe the cilia get a little bit less active and the canal get more narrow or whatever, but that we can keep through our explorations and our awareness, we can keep these channels open and alive. I think that it's really, really interesting. And lining the central canal and the ventricles. Then and they then that led me to this to explore more or to research more the ventricles and their position, because the ventricles, like the hemisphere grow out of these ventricles, and it starts as a tube, as a central canal, and then it goes to the sides, to the lateral ventricles. It's above the thalami or the thalamus, and so it kind of it's higher, and the hemispheres are around that, which directly leads to this image, which is similar to what Bonnie was drawing, um, starting here, like on the left, as a tube, already defined with the three major parts, and then differentiating more and more and bulging to the sides. And the biggest bulge is here on the top. And this is I enlarged it here. It's this layer out here, the big layer, it becomes the lobes. And this deeper layer, which is over, this is the thalamus and the hypothalamus, the ancient forebrain. And this layer directly above the ancient forebrain, which comes out of this folding of the lateral ventricles, is become the limbic structures, the amygdala, hippocampus, basal ganglia. And so it's a kind of a layering, of a multi-layering, like the brain develops from the inside out. So it starts like in this image, it starts as just as the tube, and then from there first it grows up, and then it grows to the sides. And then out of that growing the different lobes. And here what is called limbic lobe, this is the cingulate gyrus, or the cingulate lobe. And so this image is just a summary of what we have been explored, but it's clear here that also evolutionary, we share this basic structure, the brainstem and the midbrain and the ancient forebrain. We share with it goes million years back, so it's very primitive. Vertebrates already have that brain structure, but then the limbic and the cortex are added in the evolution. And so it's visible here, this layering, and then also the folding forward of the brain. And the key playing what the eyes, what Bonnie mentioned also, the visual stimulation here, the optic chiasma, which is the crossing of the optic nerves, and from there the nerves go to the thalamus, or to the thalami, to both sides, and from there, from the thalamus, they go to the occipital lobe in the visual cortex. That's another image, I think, with the optic chiasm directly in front of the hypothalamus. And this line here is the, how is it called?
Lamina terminalis.
The lamina terminalis is this one here. And then you see the hippocampus, it directly above the thalamus, which is, it's already part of that deeper folding of the cortex growing out of the lateral ventricles. And here the corpus callosum, and also that what Bonnie was saying, that the growing up from the insula, the connection of the insula, which is somewhere also in this area, and then growing up into cingulate cortex. And this shows a little bit more in detail the limbic structures, and especially these two structures, the basal ganglia, which are organizing the movement, which on the end of the this round structure here is the amygdala and the hippocampus. So and this is more the emotional regulation. So you have emotional regulation and movement regulation. And they're covering the thalamus. They're on top of the thalamus and the hypothalamus. So the ancient forebrain is kind of nesting or snuggling underneath this deeper layer of the cortex, which is the limbic system. So I was thinking, how can I so for exploring another image maybe, and this kind of tubes, and then I put in front of a red tube. So we were talking a lot about this the front of the spine and the back of the spine. And that the front in the spinal cord originally it's like half, and in the spine it's still like that. It's the half of the spinal cord, the front is motor and the back is sensory. But then when it grows up into the brain stem, into the midbrain, and into the ancient forebrain, the back part becomes bigger, and it's like like this balloon, and it's growing over the notochord, and this becomes the whole cortex. And then nested down here, underneath here, are the limbic structures. But maybe we can think about that in this way, in this way, that the back, this more growing out of the sensory part, is growing over to become the hemispheres. Okay, then let's just move a step back to this ependyma, or the ependymal cells, and just where you are in this moment, if you sit, stand, or lay down in any position. And for a moment, just feeling um, your weight, just feeling your weight and your left side, your right side, just so coming back to some of the things we were exploring before. Um, the development of the cells on the right side and the development of the cells on the left side, all the way up into the brain with the right hemisphere and the left hemisphere. And again, if we want, we can just shift a little bit the weight to the right, a little bit the weight to the left. So I'm putting maybe your hands on the right and left side of your head. So you, with your imagination, you can touch the outer surface of the hemispheres. There is the skull, and then there is the membranes, the meninges, and then the lobes. And there's a right side and a left side. And deeper underneath the lobes, there are the ventricles. And the ventricles start from the neural tube, on the closing of the neural tube. And so in the very first fluid inside the canal is the amniotic fluid, and then it closes on top and bottom and creates this closed tube, which is growing much, much faster and more on the top, and starting this canal, this narrow canal starts up in the brain, starts to bulge, to expand, to create the different parts of the brain. And then on the top, it starts to grow even more to the sides to create the lateral ventricles. So and the lateral ventricles are not only growing up, but they are growing down and then a little bit to the side and a little bit down. So maybe for a moment also seeing or remembering the pictures before, trying to find this inner fluid space in your spinal cord, the central canal, and in your brain, the ventricles, third and fourth ventricle, and the lateral ventricles. And then adding to this image of the central canal, the ventricles, and the opening to the sides, the lining of the ventricles, the lining of the central canal and the ventricles, there are these ependymal cells, which are a kind of glia cells. And these glia cells lining all the inner surface of the canal and the ventricles, already very, very early, already when there is the simple tube starting to bulge and open in the top. And these cells have little hairs, cilia, and these hairs are facilitating to move the CSF up. So they facilitate the circulation of the CSF, the cerebral spinal fluid. And with that, they move also other glial cells. And it's said that with age, that these hairs or these cilia are getting a little bit stiff, but I think if we actively imagine the flow of the CSF and the aliveness of these glia cells, of these ependymal cells, we can keep them alive and keep them going. And especially if we keep the spine soft and moving. And so we're continuing to shift a little bit to the right, a little bit to the left, continuing to visualize the two sides, and shifting a little bit forward, a little bit back, and maybe rotating a little bit to the right, a little bit to the left, side bending. So all the three dimensions, and how through this three-dimensional movement, the inner canal of the spinal cord, and with that, this ependymal cells or the ependyma get stimulated like a snake or a serpent in facilitating the flow of the CSF in the central nervous system all the way up to the lateral ventricles. All the way up to the lateral ventricles, which are above and a bit in the front of the thalami. And as we going all the way up to the lateral ventricles, also there is this automatic movement of a little bit folding forward and backward and folding forward, as if we're making kind of snake-like movements in the spine, kind of waving movements, allowing going through the spine and the spinal cord. And out of that, out of these lateral ventricles, the cortex, the hemispheres are growing, growing, growing. And as they grow from the back, they are folding forward to create the forebrain. And they're growing from the back part of the spinal cord. The back part which created also the thalami, while the front part, the little red front part, created the hypothalamus. But then there is one more movement, so it's growing forward, so it creates this movement kind of. If we make this movement, it's like a rotation of the head together with the bowing of the heart, the bending, the folding of the midbrain, creating this forward movement. But then the whole hemispheres the lobes are folding back to create the lateral lobes. And by this folding, there's the counter movement. So there is first the folding forward, and then the rotation of the hemispheres to create the lateral lobes. And by that creation of the lateral lobes, the deeper structures of the cortex are covered. And that is the insula and are the limbic structures. And the limbic structures are part of the modern forebrain, but they are covering, in this folding process, they are covering the thalami. They're just above the thalami. But really, the thalami are nesting underneath these limbic structures, which is more in the back, it's more the basal ganglia, and in the front, the amygdala structures. And still keeping the sense of space in the center of the brain, in the central canal, all the way up in the bulging of the third and the fourth ventricle, and the opening into the lateral ventricles, and expanding in the hemispheres. And then just above and forward of the thalamus, there is this structure, this double structure called the septum pellucidum. And it's very much in the middle, but there are two membranes with space and fluid in between. And this is the midline structure in the brain, forward and up of the thalamus, which creates another kind of midline. So if you want to bring your hands together above the forehead, and there are many also practices which have that this gesture. And if you bring that together with the bowing of the heart, folding of the midbrain, and then the rotation of the, almost like now I've got like the image of a ram, like a, you get this movement, this fluid undulating movement, which is not just the head, but it's the whole spine. And then if we want to add to the sagittal movement, again, the side bending and the rotation, and with the rotation, also the possibility to cross the midline. So to establish the midline and to cross the midline. But continuously with this idea, and you can add also the notochord as a flexible structure, as a place of orientation, even before the neural tube and before anything. And then how the brain folds over the notochord and the pituitary in the front, pineal in the back, in the front of the lateral of the fourth ventricle, and in the back of the fourth ventricle. And still the cells of the right side, cells of the left side, cells to brain, and then brain to cells on the opposite side. And the epidermal cells on the inside of the central canal and the inside lining the ventricles. And allowing also your limbs, your arms to come into play, to participate in the movement, to allow these subtle gestures of your central nervous system to be expressed also in your arms. And so this gesture, this embracing gesture, this kind of second phase or completion of the motor reflex to allow the completion is also resonating with the sensory coming in the back and the motor going out into the front. So the and then take another few minutes. If you like to continue with whatever you comes up for you in this moment, what interests you, what is coming to the foreground. Or just rest, absorb, letting the cells inform your brain. Or write. Or use your voice. If you want to do this for a moment, just to kind of locate the insula on both sides, and the rotation of the hemispheres, which is explored a little bit earlier. The rotation of the hemispheres is around the insula, so it's around the insula, and then the lateral lobes coming forward and covering the insula. And so if we take the insula for a moment as the pivot point, and we just move the head forward and backward, and we move the hemisphere forward and then backward, and the insula is the pivot point to move the hemisphere first forward and then backward. And then we already feel in this movement that if we put more weight on the insula, or when we lift weight from the insula, how does it feel to kind of weigh the brain on the insula or lift the weight off the insula? And as we lift the weight off the insula, going diagonal back into the brain and open to the hemispheres through these projecting fibers, the cingulate cortex or the corona radiata. So playing with this weighing on the insula and putting off the weight of the insula. And then level underneath the play between the thalami and the hypothalamus. A more primitive level. And above the thalami, these ventricles. So the ventricles are the lateral ventricles. So they give a support to all these structures. And then in between the limbic structures, the amygdala more in the front and the basal ganglia in the back. So it is putting that all together to put more weight in the front of the brain or opening to the back and up. And then this septum pellucidum in the middle. Like Bonnie often says, like a prayer. Just take a few moments more, just rotating your head around the insula, charging the insula and relieving the insula, keeping your spine soft, and your shoulders and arms with a sense of weight.